welcome to the video lecture on Introduction to Labview. So in today's lecture we will see what are the basic block diagrams or windows in Labview, how to operate Labview, and later we will implement 4:1 multiplexer using Labview. So today's lecture is on implementation of 4:1 multiplexer using Labview. So first I will give some basic introduction about Labview, how to open Labview software and what are the basic blocks or panels available in Labview. So any program in Labview is called virtual instrument. So all files are here are in Labview is called .vi file. Vi stands for virtual instrument. Okay, so today's lecture, now we'll see what are the basic panels in Labview. So panels or windows in Labview. So basically there are two panels. One is called the block diagram panel and the other one is called front panel. So first one is block diagram panel, and the other one is called front panel. So block diagram panel is basically implementation of a system using block diagram, right? So whatever system we want to implement, here everything in terms of block diagram implementation. So here this is block diagram implementation of system using block diagram. Okay, and in the front panel this is input and output functionality. Okay, so here this is your observation window. So all the basically functions regarding the input output, it will be observed on the front panel, and block diagram panel is the implementation part. Okay, so now we'll see how to open Labview. And so this is the window. If you click on the Labview icon, it will open as getting started. So in the right hand side you will find the documentation regarding the Labview programming. So they have documented nicely with a very small program to a actually high level program. So you can read, you can go through all these documents. So to open a new program, you have to click on blank VI. Okay, so if you click on blank VI, it will open two windows. One is called block diagram, as I said, and the other one is the front panel. So block diagram window and the front panel, if you press Ctrl T, this will open in side by side so that your view will be better. Now if you click on the block diagram panel, right click, then you will get some option regarding functions. So these are the functions which are available in Labview. So these functions are input, signal analysis, output, arithmetic and comparison, execution control, and signal manipulation, etc., etc. So these are the most commonly used. If we click on the down arrow, it will give you all the functions or all the block diagrams which are available in Labview. So based on some sections like actually programming, then measurement IO, instrument IO, vision and motion. So all those structures you will get in the functions buttons. Okay, and in the front panel, if you right click on the front panel, it will give you options which are controls. So these are basically input output controls and your observation window. So in graph indicator we will find graph plot, chart plot or XY plot, and there are some control which are called number control, then dial, knob, and here you will find the push buttons, toggle switch, etc. etc. Okay. So now today we are going to implement 4:1 multiplexer using Labview. So just a brief about what is 4:1 multiplexer. So multiplexer is known as data selector. So 4:1 multiplexer has 4 input lines and 1 output lines. Okay. So if you draw the truth table of this, we'll take some other pen. So if you draw the truth table, so there are basically 2 select lines, 4 input and 1 output. So these are S1, S0 and Y is your output. So what are the possible combinations? Possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So according to this select line, the Y will take I0, I1, I2 and I3. So these are the 4 inputs. Okay. So if you write the expression of output, we can write like Y equals to S1 bar, S0 bar, then I0 plus here S1 bar, S0, S1 bar, S0, I1 plus S1, S0 bar, I2 plus S0. Sorry. So this is S1. So S1, S0 and I3. So this is the expression for the output. Now we'll see how to implement this expression using basic gates. Okay. So this portion is AND gate. So these are all AND gate. And all together is summed or OR gate. Okay. So basically you have 4 input lines, I0, I1, I2 and I3. 2 select line, S1 and S0. So S1 and S0. Okay. So you need S1 toggle or S1 bar. So we'll take one line which is S1 bar. This is S1 and here one more toggle line and yes. Okay. So at the output there we need 4 AND gates. Okay. So first we will connect this. So I0 is, so first output is I0, S1 bar, S0 bar. So S1 bar, then S0 bar. So these two are connection point and I0. Okay. Next is I1, S1 bar, S0. So I1, S1 bar and S0. Right. So these are the output for this AND gate. Now third one is I3. Sorry, third one is I2, then S1 and S0 bar. Correct. And the fourth one is I3, then S0, S1 and S0. Okay. Now this, the output of 4 AND gate will be OR together. So we'll take a 4 input OR gate and we'll connect the output of this 4 AND gate to the input of OR gate, and this one will give you output Y. Correct? So this is the implementation of this multiplexer using basic gates. Okay. So now we'll come to the implementation using Labview. So these are all input are nothing but push switch. Okay. Yes. Now we'll come to the block diagram. So first we have to select input and output. So first we will click on the front panel, go to buttons, then we will select push buttons. Okay. So we need 4 push buttons. So what we have to do is go to block diagram panel, select this boolean, and you can copy Ctrl C and Ctrl V paste. So we need 4. So 4 these input switches we have taken in the block diagram panel. So same 4 switches will be available in the front panel also. Okay, we'll just select. So these are 4 input switches, which are nothing but I0, I1, I2 and I3. Right. Now we need 2 select lines, which is S0 and S1. You can change the name. So better we'll change the name to, this one is I0, I1, and here it is I2, and this one is I3. Now we need 2 select lines, so we'll take 2 more toggle switch. So right click, go to buttons and take toggle switch. So these 2 will be acting as a switch or the select lines. So same thing again, copy and paste. So this one will take copy and we'll put it here. So 2 select lines and 4 inputs. So this select line we can name as, so this is S1 and the other one is S0. Okay. Now we need to implement the multiplexer using gates. So as I shown in the diagram, so we need 2 NOT gate, 4 3 input AND gate and 1 4 input OR gate. So we shall come to the block diagram panel. Here if you right click on the block diagram panel, functions window will come. There is an option arithmetic and comparison. There we will find a option called boolean and go for NOT gate. Okay. So NOT gate will paste here. So this is one NOT gate. Again same thing, Ctrl C and Ctrl V, copy paste, and we'll connect to the other one. Okay. So now this line will give you S1 and this is S0, and this one S1 bar and S0 bar. Now we need 3 or 4 3 input AND gate. So right click on the block diagram panel, click on this icon, down arrow. Okay, go to programming, here boolean, and there is a compound arithmetic. Select that block, paste it over here. 1. So we need 4 of this. So again we will same thing. We'll take 4 copies of this block we'll put it accordingly. This is the third block. This is the fourth block. This one will shift somewhat outside. Okay. Now we need 3 input AND gate, but here it is only 2 inputs, you can see. So if you drag this to down, it will give you one more input. Here also same thing will do, one more input, and here if you drag down, then it will give you one more input. So now it has become 3 input arithmetic functions. Now you have not defined it that this is a AND gate. So what I have to do is just click on this V letter. Okay, just click on this V letter, it will give you change mode, and then make it AND gate. Do it for all. Change mode and now it has become 3 input AND gate. Now first block is, now we'll see what are the connections. So S1 is connected to third and fourth. S1 is connected to third and fourth. S1 and here is third and fourth. Now S0 will be connected to 2 and first. So second one and the first one. Okay. Now S0 is connected to second and fourth. S0 is connected to second and fourth. So S0 is connected to second and fourth here, and S0 bar will be connected to first and third. Okay. Now the other input is nothing but input symbol I0. Here it is I1. Here it is I2. And for last AND gate it is I3. Okay. Now we need one 4 input OR gate. So again come to block diagram, right click, click on the down arrow, go to programming, boolean, and then compound arithmetic, and paste it over here. Now we need 4 input, so drag it down till it gives you 4 inputs. So first output of the AND gate will connect to the input of OR gate. Here also, and third one, and accordingly to the fourth one. Okay. Now at the output we need a indicator which will show if it is binary 1, that light should glow. If it is binary 0, then it should not glow. So for that we need output. So we'll come to the front panel, click on this front panel, go to LEDs, and we'll select a LED which is round LED. So we'll paste over here. Okay. So same thing will be appearing in the block diagram also. Just put it over here and connect the output of the OR gate to the input of the boolean switch, or actually boolean indicator. So now our design part is completed. So now we'll see how to execute. Now to execute you have to press this button over here. So this is the run button. Okay. If you press run button, this will be executed for only once. If you want to run it again, you have to press it again. So now if you press this button, then so now S1 and S0 both are 0, 0. So if you run it, then I0 will be reflected at the output. Now if you press, so output is 0. If you toggle this condition, now if I naught is 1, then your output will become 1. So it actually doesn't depend on the other states. Now if you turn on this, output will remain the state of I naught. Correct? Now if you want to run it for infinite time, so that runtime you can change the state of S0 and S1 and you can observe what are the changes at the output. So for that, you right click on the block diagram panel, there is a execution control, and from there you select while loop. So this is a infinite while loop. If you select the whole structure, if you put the whole structure inside this while loop, the structure will be running for infinite amount of time, and as long as you stop the button, here is a stop button or abort execution, this will be stopped. So now if you run this structure, this will be running for infinite amount of time. Now S1 and S0 both are 0 0, so output state depends on I naught. You can see over here. Okay, if I change the state of S0 to 1, then it depends on state of I1. If this is 0, S1 is 1, then it depends on I2, and both are 1, then it depends on I3. So this is a simple implementation of 4:1 multiplexer using Labview. So if you want to stop or abort this program, you have to click on this stop button, then your program will be stopped. Okay. Now we'll see how to create a sub VI. Means we can use this structure to some other program. We no need to implement all the structure using logic gates, all this structure. We can create one sub block of this structure and we can use in some other VI. Okay. So for now we'll remove this while loop. So what you have to do is, so what we are going to do here is, first we'll create a block diagram which is 4:1 marks. So it has two input lines which is S1 and S0, and 4 input lines, 2 select line and 4 input lines. So this one are I0, I1, I2 and I3, and output is Y. So this structure will implement, and in some other program we'll give this 4 input directly and 2 select line, and we can observe the output. So now we'll see how to create sub VI. Okay. So for that, what you have to do, go to block diagram panel. There is an option in the right corner. There is an option over here. So if you right click on this and then edit the icon, then it will come this window. Go to this, select this picture and delete it. Then you put one more square. Inside that, to write something, you press on this A and write something over here like multiplexer. Okay. So this icon will be showing as a marks. Now press OK. Then the icon is changed. So now come to the front panel, right click on this marks icon here and show connector. Like instead of showing this icon, it will show the connectors. Now what is the type of connector you require? So the connector required is, so 4 inputs, 2 select lines and 1 output. So this is I0, I1, I2, I3. These 2 are select lines, S1, S0, and this is output. So we need this type of connectors in the front panel. So we'll come to front panel, we'll right click on this connector icon, go to patterns and we'll select which is suitable for my implementation. So we'll go to this structure which is suitable. So we'll click on this. So this icon will be changed. Now we need to assign these are input, these two are select line, and this is the output. So for that, what you have to do? Click on the small box here and assign it to I1. Next, click on the second, assign to I1. Click on the third, I2, and fourth one is I3. Similarly, this one we assigned as S1, this one S0, and the last box is your output. So now we have assigned all the input output terminals of this connector to the input output blocks of the program. Correct? Now you save this file, save, we can write as a marks design or marks. So this is marks design. Now you save this block diagram. Okay. Now you can close this block diagram. Okay. Open one more VI. So I want to use that marks design VI to some other VI. So open a new VI, press Ctrl T, and then right click on the block diagram panel, select a VI. So there is an option called select a VI. If you click on this, it will ask you to select a structure. So select this marks design block or marks design VI and paste it over here. So directly it will show you what are the input output ports. So now see, this is I0, I1, I2, I3, and these two are select lines, and this is the output. Okay. Now same thing we'll do it here again. So we'll select some push buttons. Okay. So we need 4 push buttons. Okay. So this one we'll take it over here. And this is the fourth one. Now we need to select lines, go to buttons, then toggle switch. So 2 will appear here. Okay. And one output. So for output we need LED indicator. So round LED. So now this is my structure multiplexer. Now we need to connect this structure to this block. So what we will do? So this is, I will change the name again. So this is I0, this I1, I2, I3. This is select line S1, S0, and this is output Y. Okay. So now S1, as I said, so this one I can put it down so that my connection length will be less. So S0 will be connected here. Here it is S1, then 4 input points I0, I1, I2, and the last one is I3. Now the output should be connected to the LED. Now this is, the structure is now implemented. Correct? So if we run this now, it will select the input based on the select lines. So now S0 and S1 both are 0, 0. So only I0 state will be reflected at the output. So if you run this, then I0 state is now off, so output is off. If we click on this, then output state will change. Again, if I put S1 equals to 1, then the state will depends on I1. So now it is off. If we turn on and run it again, it will be off, on, right? So similar functionality. So if both are 1 1, then it depends on state of I3. So now it is off, turn on I3, output will be turned on. So this is the method how to use a VI in some other VI, or it is known as sub VI implementation of 4:1 multiplexer. Okay. So in today's lecture we saw some of the basic features. One is how to open Labview and panels. Second one we observe is implementation of 4:1 marks using Labview. And third is sub VI and implementation of 4:1 marks using sub VI. Okay, thank you.